Hi, and welcome to Mr. Garofalo's podcast. In today's episode, we are looking at the back pages of the Gayles Garden activity, which is called Exploring the Symmetry in Quadratic Function Graphs. So I just want to take you through a couple of the steps that you're going to want to do on this assignment tonight. The first page has two parabolas that have been graphed for you and asks you to complete a function table for them. I'll just do a couple of points. I'm pretty sure you have this idea, but some of the points are labeled on the parabola, as you can see, and some of the values are empty. So if we look at the first row of the table, it gives us negative 1, 8. So if we go to negative 1, 8, we see that's this point here. And we also see 2, negative 1, which is plotted here, and 4, comma 3. So if we use some whole number values here, we let x equal 0, we'd find that the parabola has a y value of 3 when x is equal to 0. So we'd put 0, comma 3 in our table. That also happens to be the y-intercept of the parabola. It's the point where the parabola strikes the y-axis. Now you continue doing this, and you would find that for 1, the value of the output is 0. For 3, the value of the output is also 0, 4, comma 3, and then 5, negative 1. So on the next page, you'll be taking some of those characteristics that we discussed in class and looking at the graphs to determine them. The first one up is coordinates of the x-intercepts. Let's go back to the graph, see if we can find that. Remember, an x-intercept is a point where the graph hits the x-axis. Notice this parabola has two x-intercepts, here and here. If you look in the table, they can be found in these two rows. So the x-intercepts are 1, comma 0 and 3, comma 0. The coordinates of the vertex or turning point, I think that should be a pretty easy one for you. Let's go to the next one. Does the vertex represent a minimum or a maximum? Well, in parabolas that are U-shaped, the vertex is the lowest point on the graph. Since it's the lowest point on the graph, we call that vertex a minimum point, as opposed to parabolas which are arch-shaped, in which the vertex is the highest point on the graph. And those are called maximums. So you need to determine which one is for which graph. The equation of the axis of symmetry, if we go back to our graphs here, the axis of symmetry is always going to be a vertical line through the vertex or turning point. In this case, that would be your axis of symmetry there. And the equation of that line is x equals 2. Points of symmetry. Find f of negative 1 and f of positive 5. So I can look in the table or on the graph. For negative 1, it's 8. Positive 5. Oh, look at that. I made an error. 5 is also supposed to be positive 8. I'm not quite sure why I put negative 1. I'm not sure what I was looking at. That would be right down here. That doesn't make any sense. That wouldn't be symmetric. This is supposed to be 5, comma 8. So notice these are points of symmetry. 5, comma 8 is 3 units from the axis of symmetry, and negative 1, comma 8 is also 3 units away. They share that distance away. They're actually reflections of one another. So our points of symmetry here, f of negative 1 is 8, and f of 5 is also 8. Is f of 7 greater than or less than 8? Let's go back. And here's 7. As we look, we can't see that anywhere on our graph, and we don't have 7 in our table. But let's think about what's going to happen here. This parabola is going to continue up in this direction, increasing. If 7 is over here to the right of 5, and f of 5 was 8, well then f of 7 will certainly have to be greater than 8. This has got to be greater than. On what interval the domain is the graph increasing or decreasing? Well, your axis of symmetry can help you here. Anything to the left of the axis of symmetry is your decreasing part. Anything to the right is the increasing part. And lastly, average rates of change. Now, if you didn't get the correction in class, I'm going to give it to you now. This one should say -4. This one should say -1. That was a mistake on my part, the bottom right corner. Let's go back to graph A. So asking, what is the average rate of change from -1 to 0? So we can go two places. We can go in our chart. We have a decrease of 5 and an increase of 1. So that rate of change would be -5. Then from 0 to 1. Well, from 0 to 1, now we have a decrease of 3 and an increase of 1. So that rate of change would be -3. Notice how the rate of change is variable. It's not constant. From 0 to 3. From 0 to 3. So it would be an increase of 3 in the air input. This would be a decrease of 3. So we'd have -3 over 3. The average rate of change there is -1. And lastly, from 1 to 3. So from 1 to 3, the change in the inputs would be 2. And look at that. There is no change in outputs. 0 over 2 will be 0. That's interesting to note as we look on our graph. Here's 1 and here's 3. So from 1 to 3, the graph dips down and decreases till it hits the vertex and then comes back up. But notice, it hasn't changed its y value at all. It's still at that same level, still at 0. So sometimes the graph can actually be easier for rates of change. If you just look, well, look at that. It hasn't really gone up or down since it went from 1 to 3. It's at the same point. So that rate of change is 0. You're going to repeat this for graph 2, or graph B, excuse me. Best of luck, and I'll see you in class.